Thanks for coming along to this. Hope you've all had a beer and some food and you're enjoying yourselves at Build. My name's Andy Wigley. I'm a software development engineer in our developer experience group. The last couple of months, I've been totally devoted to Cortana Skills, working with a lot of partners to help them to adopt this new technology that we've been really excited to open up to you guys starting at Build today. So with me, I've got David Hamilton, who's a partner I've been working with. David, do you want to just tell us about your company and what it is you do? And
yeah, hi. So I'm David. I'm the CEO and founder of GigSeeker. We are a live music discovery service. We have basically built our service on Azure. We go around and collect data around artists, venues, events, etc., and collate all that together, and then we send that out to our consumer services. In this instance, we're using the bot framework, which sends it off out to GigSeeker. However, as we move forwards in the future, we're also expanding our services to cover other events such as comedy or even theatre and that type of stuff.
so you're building with the bot framework, but you're using quite a lot of other Microsoft technologies in your solution, aren't you?
Yeah, so we work with Bing Translator for our services as we launch them in France and Germany later on in the next couple of months. We also, well, all of our services run off Azure in the background. We are using the bot framework and therefore Cortana Skills. We've got client apps coming out in the not too distant future which are built off the Xamarin system. So yeah, we're using quite a lot of them.
But of course, ultimately this is a music-focused search facility. So you're making use of Azure Search because you've got like a vast array of data that users can search using natural language. So do you want to just tell us about how you've enabled that searching to be really efficient?
Yeah, so we started, well, a few years ago, we were building up our data and we were obviously having to search through it. And we were building our own search system. And as we started to add more and more data in there around the world, it just got slower and slower and slower. So Azure Search was kind of our answer. And it's really simple. I'll just show you. He says, cool. So here I am in Azure. I'm on the Azure Search side of things. And very, very simply, I'm just going to connect to an existing data source I got. So we use Azure SQL in the background. I have a view of some of our data that it already extracts things. So here I just click on import. I can connect to the data source that exists. It's just a test. Select my database, and we have far too many. And fingers crossed that connection should work. Once I'm connected through, I can just go ahead and select a table or a view, whatever it is contains my data. So in this instance, we've got a view for searchable profiles. Once I've created that, it goes ahead, analyzes my data, and it will pull through the columns that we have available from our data that I can now add into Azure Search. So really simple here. We can start to see I've got things like an ID, which is going to be my sort of key of everything. I can see names for profiles. I can see type of profile, whether it's a venue or artist. So I can select those as being retrievable information from our data source. But likewise, I can go ahead and I can select what becomes searchable data. So do I want to type in an artist name? You get the idea. So to show one I made earlier, this is now our live service that's running within our own Cortana skill at the moment. I can go ahead and I can just do a search directly against this. So I can type in Bruno Mars, and almost immediately I get search results starting to come back. Down here I can see that Bruno Mars is the first result. We've also got other artists, Bruno and Charles Bruno, that might match. As a system, that took us a matter of minutes, really, sort of 20 minutes or so to put together there and then code into our service. So it's really, really simple, REST-based API and super quick to set up.
So that really efficient searching is sort of the real core of your solutions. Where does the data come from for a live music discovery service?
So our data comes from numerous places. We work with various different ticketing companies around the world and pull data feeds from them. We also work directly with venues, artists, promoters and get the data from them. And we also have a team of in-house staff that are collecting that data and put it together. So amongst all of that, we're collating all that together to create this super accurate, super detailed set of data.
Cool. So you've got this big database of data about artists, about events, and about venues. And you wanted to create a Cortana skill and other services. You created a bot, so it's not just about Cortana skills. You guess that bot will be there to service all kinds of queries. But obviously, with natural language, you've got this real flexibility in how people want to navigate. There are all sorts of questions like what's happening in Seattle, or when's the next dates that Bruno Mars is playing, or well, I wouldn't ask that, but you might want to. So how can you now kind of dig into how you have used Lewis to enable natural language queries and I guess this is kind of chain of references. A user might start with saying, tell me about Bruno Mars, and then say, okay, what upcoming concert dates has he got, and what venues near me is where, so you've got all these very kind of complex queries that a user can make of your data. So how have you handled that?
Okay, so we started probably like everyone else is going to. We put together our sort of dialogues that create our user journey through the bot. So we've got our route dialogue that comes in. We've got event dialogues that give details around the events, artists, venues, and search dialogues. Behind all of that was a Lewis model. And this worked really, really well to start with. We could search, we could pick up artist names, venue names, location, date ranges, genres of music, all that kind of stuff. Absolutely awesome. So
where did that stop working for you?
It stopped working as our journey became a little bit more complex. We started putting it into practice, and we found that some of the things I wanted to talk about on an artist side of things, so adding the specifics of next event for an artist or upcoming events, started to then detract from the accuracy of the search intent that we built. And as we built more and more intent, sort of 30 or 40 in total, so that accuracy started to fall apart slightly.
So you had to come up with a new model for making sure that the whole thing worked efficiently.
Yeah, so we took us a little while to think of this. We had to sort of abstract the way that dialogues work and inject in the background of there the ability to include support for multiple Lewis models all at once. So here you can see over at the bottom on the far left, I've still got my route dialogue. This is the entrance place. Behind that, we've got the search functionality, and we've also got core application functionality. Whereas we look at the artist dialogue at the bottom in the middle, you can see there's sort of profile-specific things and next events. It goes all the way up and still enables search functionality and core application functionality within there. So maybe the best thing to do is show you a couple of those.
Yeah, should we go into Lewis and show us some of this stuff?
Okay, so within the GigSeeker app, these are all the different Lewis models we've got running at the moment. Our main one is this GigSeeker search, of which there's just one intent in there now, just the search. But we have a whole host of entities. So you can see at the top artist name, artist type. Are they a band? Are they a group? Are they a DJ? You get
so this is your super flexible searching dialogue that can handle all kinds of queries and pick out the appropriate entities.
Yeah, for us to be able to do the search to the sort of specifications that users asked us for, we need to understand all these various different entities within that phrase that they say.
So can we look at some of the utterances and see how that works?
So to give an example here, if we go back to the search, I can in fact look at suggested utterances, things that people have been saying to us today.
So this is live today. So this is kind of some of the stuff that people have been asking, that some of them have been correctly searched and others, they're all search ones in there, yeah.
Yep. So we can see, for example, at the top, someone's been searching for information about the Gorillaz. They're a band, but it's spelt slightly wrong, so it hasn't picked it up. So I here could very simply just go and tag that as an artist name so it remembers it for future reference. You can also see, if I turn onto the actual text that's come through, the second one down, someone's been asking what's playing in Seattle next week. And if I look at the entities that have been picked up, it's recognized Seattle as being a location and next week as being a date time object. So I'm then able to utilize this information in my code and produce the right results for the user.
So once you've done a search, you then want to sort of drill down and you know, as a user said, okay, tell me about Bruno Mars, but then if they then say, you know, when's the next events or something, how do we then sort of switch to a new Lewis model to kind of handle the follow-on questions?
Yeah, okay, so that is then handled by a different model in itself. So we have our sort of base profile model here, which handles various things like I want to find information about an artist, or add the artist into one of my favorites, or find their next event, or all of their upcoming events. So in this example, this one comes into play when I'm on that artist dialog, and it means that I'm able to query this Lewis model to check to see if I'm looking for next event, etc. But at the same time, I can always go back and check the search model to pull through entities of other artists' names. So they might be talking about Bruno Mars, but then suddenly say, when's Adele playing next? And I've got to take that context into perspective and do the right thing with it.
Okay. Do we want to show the skill? Do you want to show some more stuff in here, or shall we?
We can go on with the skill if you want.
So this is about the most challenging environment you can imagine for doing speech-activated applications. So we're going to we kind of think we've got something that will work, but cross fingers for us here.
Use GigSeeker.
Can we turn up the audio on the PC, please?
Okay, so what you won't have heard is that's obviously come back. It's recognized me as being the user, and it wants to know what I want to do today. So I should, fingers crossed, be able to ask it, find Bruno Mars. Hold on.
Sound guy, can we have number 1 up, please?
It's not plugged in.
Okay.
There, end. We'll just give that a second to see if...
Oh, it was on headset, wasn't it? Yeah. That sounded, I heard that, yeah. So you need to change the output.
Oh, wrong one.
Yeah, we're on, yep.
Sorry.
Right, let's start that again. Use GigSeeker. There we go. Use GigSeeker.
Oh, Dave, what's occurring?
Find Bruno Mars.
So sorry. Yes, I'm here. Let's see what I can find for Bruno Mars. Here's Bruno Mars. What next?
What's his next event?
So we're going through different Lewis models here.
Bruno Mars has 50 events coming soon. The next event is Bruno Mars at T-Mobile Arena in Las Vegas.
Yes, so we've gone through a few different things there. So first of all, Ask GigSeeker just brought me straight in onto that root dialog with an intent list launch. My service recognized that and welcomed me in. I then asked for find Bruno Mars, so it's using the search model from Lewis. It recognized Bruno Mars as being an artist name within that, sent that off to Azure Search. Azure Search came back with search results, found an exact match to Bruno Mars, and therefore displayed the Bruno Mars information on the screen. I then went and asked what's his next event. It looks through our data for the events on Bruno Mars, pulls that out, and therefore that's then been displayed. So simple.
Simple, eh? Gosh.
Ish.
Well, isn't it great when these applications are simple? So that was pretty cool. Yeah. So that's a Cortana skill. Shall we talk a little bit about how you turned this bot into a speech-activated bot? A speech-enabled bot?
Yeah, okay. So there's a few things there. So couple of things that we came across that you've got to remember. First and foremost, spoken text is not necessarily the same as written text. If I just go back to my screen quickly. So here, a snapshot of our code. You can see the highlighted area. I'm saying that, is the activity Cortana? If so, I'm just going to add the reply that I'd normally be sending out to a string, which I'm saving for later. If it's not Cortana, I'm going to post that. So if it's on Skype, etc., it will come out as a normal message.
I'd just like to back that up, actually, because if you just simply speak out exactly what is shown on the screen, that's actually irritating for an end user. It's like, yeah, you need to kind of craft the spoken UX independently of what's shown on the screen, or where you've got Cortana like this, where you've got a screen and audio, you can use the two very effectively together to give a good experience.
Yeah, and we found that actually in our early days of testing this. We'd list someone's 50 upcoming events, and I'd sit there for 20 minutes waiting for Cortana to finish telling me what's going on. So you really have to think about what's happening and just summarize the information via speech, utilize the screen to help present some of that information.
Cool, cool. So what about the microphone control? Can you tell us something about how you do that?
Yeah, so you'll see that in Cortana, and again, if I just give another quick demonstration here. Ask GigSeeker for events in Seattle this week.
Just a moment, please. I have 3 events that matching your search. 1. Testament, add the showbox. 2. Everclear, add showbox so do. 3. Congos, add the showbox.
Okay, so you can see from that that, first of all, it came back and said, 1 moment, please. I wasn't expecting an input from the user at that point. I was just letting the user know that I'm thinking and I'm waiting, I'm doing something. And then we come back again with more information. So to do with that, I've got to set input hints on Cortana.
Because actually Cortana is a turn-based system. So, but the cute thing is you can send back a response from your bot, but tell Cortana that, hey, I'm not interested in anything the user says. I'm going to follow up. Effectively, then the Cortana returns with an empty turn. You can then send another message. So it kind of gives the illusion of async messages being sent from your bot. And they follow, they back up one after the other.
Yes, and that's done by setting this input hint here. So I have to synchronize the dialogue state with whether or not we're waiting for input, whether I'm doing a dialogue wait, with the input that I'm then sending out to Cortana. So here, if I am waiting, I'm saying that I'm expecting another input from the user. So the microphone at that point is turned on straight away, and the user can just go ahead and send some more information to me.
So in fact, those 2 properties there are the key to getting a bot to speak. We've got new properties on the message, which is, for any of you who've done bot framework dev, there's speak, where you can specify what Cortana will say, and then there's input hint, which allows you to effectively control the microphone. And that's kind of the essentials of it, isn't it, really?
Yeah, and it really is as simple as that. You've just got to think that journey through for your user, and then populate those 2 boxes.
Yeah. So anything else to just kind of point out about the speech thing?
A couple of other things that we kind of looked at. So we have issues where artists spell their name differently to how they pronounce it, or all sorts of things like that. So it's really a good idea to look at SSML, so you can get fine granular control on the actual way the stuff is pronounced by Cortana. And also, you've got to think about, now that there's the invoke speaker and etc. coming out, what do you do when there is no display? How do we tweak our journey that we're utilizing the display to help us provide that information to something that works in an entirely displayless way?
Cool, great. Right, so have you had fun building this Cortana skill?
Yeah, it's been... It's been a roller coaster, yeah. It's been good.
Well, it's like any emerging technology. There's been some frustrations along the road, but it's exciting to get to this day where we can finally release your skill and allow developers access to the bot framework to build their own Cortana skills.
Yeah, and I think for us, certainly over the last couple of weeks, as we've seen it all come together, it really is now a decent kind of product that's out there.
Yeah.
But we have a lot more to come.
Awesome. All right, that's it. Thanks very much for coming to this Code Theatre. If you wouldn't mind, we would love to hear your evaluations, and we'll be around if you want to chat to us some more. Thank you.